Imagine breaking a cube, stretch it, twist it, reshape it like a clay. We can do everything with a cube, but we can't change one single equation, one single formula. What's that formula? That formula is Euler's formula. What is that? It is E equals to V plus R minus 2. This can't be changed. This is an Euler's formula. So what is this formula? Let us discuss this today. Today, our topic is based upon Euler's formula. It is one of the most important formula in mathematics, which is used to find the number of edges in a polygon. So what do we mean by a polygon? From polygon we mean that any-sided closed figure, right? So this formula is, Euler's formula is used to find the number of edges. Number of edges of a polygon, right? And not only this, Euler's rule applies even if the edges are not straight lines. So we will understand this. We will understand this formula, and we will understand the first line, what's the next line, one by one, with the help of some examples, right? With the help of some examples. So let's take a first example. The first example is, let us suppose that we will take a concave polygon. This is a concave polygon, right? This is a concave polygon in which one angle is, it is greater than 180, right? And what's the polygon? The concave polygon is PRQS. So we will apply the Euler's formula on this concave polygon to find the number of edges, right? So in order to find out the number of edges, we will first write down the E is the number of E here. Here E represents the number of edges, V represent vertices, number of vertices, and R represent regions, how many regions. So we will discuss it, and we will understand this formula with the help of these examples. This is the first example. So we have to find this E, number of edges. So in order to find this E, we have V. So what is this V? V represents the number of vertices. So how many vertices are there? This is one vertex, this is second, this is third, and this is fourth vertex, right? So how many vertices are here? Here are 4 vertices. Okay, so plus here, and afterwards there is R. So this R represents number of regions, inside, outside. So there is one inside region, that's region first, and outside of this convex polygon, this is outside. Okay, so this is the region second. So how many regions are there? This is first inside and second one is outside. So in place of this R, we will represent 2, and minus 2 is minus 2 is in formula, right? So from this, what we get? This plus 2 and minus 2 will cancel out. So here we will get 4. So what is this 4? This 4 represents the number of edges, right? This 4 represents the number of edges. So we will count the number of edges in this concave polygon. This is one edge, this is second, this is third, this is fourth. So from this formula, we are in a position to find the number of edges, provided provided vertices are given and regions are given, right? Let's take another example of polygons. We will take another example, that is pentagram. This is a pentagram. And in this pentagram, we will find the number of edges. We will find this E. So in order to find this E, we will firstly find the number of vertices, right? So how many vertices are there? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 vertices. And thereafter there is R. So this R represents the number of regions. Okay? So we will find the number of regions. This is 1 region. This is 2. This is 3. This is 4. This is 5. This is 6. And the region which is outside, region lying outside of this pentagram is 7. So how many regions are there? There are 7 regions, right? So now we have minus 2. So 10 plus 7 is 17 and 17 minus 2 is 15. So from this 15, what this 15 represents? This 15 represents the number of edges. There are 15 edges in a pentagram. Now we will calculate the same. Okay, this is first edge, this is second, this is 1, 2, 3, 4, this 4, this 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this is 15. So it means first edge, this is first edge, second, third, 4, 5, 6, 7, 8, this is 9, 10, 11, 12, 13, 14, and this one is 15. So there are 15 edges in a pentagram, right? Let's take another example. This example is quite interesting because from this example we will come to know that polygons, the Euler's formula, not only it is not only applicable to those very figures which having the straight edges. Euler's formula is also applicable to the polygons having curved edges, right? So let's take an example. Let's have a look at the polygon. This is a polygon, right? This is a polygon. So here these two circles are having these two circles have edges, but they have curved edges, right? And this is the another quadrilateral in between them. Okay. So now we have to find. Now we are required to find the number of edges in this polygon. So in order to find the number of edges, we will firstly find the number of vertices. So how many vertices are there? This is 1, 2, 3, 4. So in place of this V, we write 4. Okay. So now we have to find the number of regions. How many regions are there? This is 1, this is 2, this is 3, and this is 4th region, and the region which is outside this polygon will be the 5th region. Okay, so how many regions are there? There are 5 regions and minus 2. 1, 2, 3, 4, 5. There are 5 regions. Okay, so 5 plus 4 is 9. 9 minus 2 is 7. So what is this 7? But this 7 is, it represents the number of edges. So there will be 7 edges in this polygon. So we will count it. This is first edge, this is second, third, fourth, fifth, and this is 6th, and this is 7th. There will be 7 edges. The 4 edges of this quadrilateral, the 1, 2, 3, 4, 5, having one diagonal. Okay, 1, 2, 3, 4, 5, and one edge and two edges are the edges of this circle. This is circle first and circle second. These are edges, but these are curved edges. So from this example, we have come to the conclusion that Euler's formula is not only applicable to the figures having the straight edges, but Euler's formula E equals to V plus R minus 2 is also applicable to the figures having curved edges. Right? So I hope you understood today's topic, which is based upon the Euler's formula, why Euler's formula is necessary in the field of mathematics, why it is necessary when it comes to define the polygons, okay, and why, whether and the second most important thing, that is Euler's formula is not only applicable to the polygons having straight edges, but also for the polygons having curved edges. And we have introspected that very thing in this polygon, because having the curved edges. I hope you understood. See you in the next session. Fi aman Allah.